fractions express division or ratio between two terms, a and b, where a is the numerator and b is the denominator. There are important rules necessary when working with fractions. If we multiply two fractions, the result is equals to the multiplication of the numerators divided by the multiplication of both denominators. If we multiply two fractions and we find that the numerator and the denominator have similar terms, we can simplify them. Division is simply the inverse of a multiplication. Therefore, for example, here we have a over b divided by c over d. What we do is we flip c over d and becomes d over c. And we multiply those terms, a times d divided by b times c. In terms of addition, if both fractions have the same denominator, we just simply subtract or add both numerators. And we just write the common denominator. If both fractions have different denominators, then we use the following rule. We multiply the numerator of one times the denominator of the other one, plus minus, depending on the case, the denominator of the first one times the numerator of the second one, divided by the multiplication of both denominators. Let's solve the following examples to illustrate how we work with fractions. In exercise A, we have two fractions that are multiplying each other. Here, this will be equals to the multiplication of the numerators divided by the multiplication of the denominators. Before we continue, let's refresh a little bit the distributed properties. If we have a times b plus c, what we do is we multiply a to both terms inside the parentheses. This is equals to a times b plus a times c. When we have two terms, we multiply the first term of the first parenthesis with each of the terms in the second parenthesis. So this is AC plus AD, and then we multiply the terms of the second parenthesis with the second term of the first parenthesis. So this is plus B times C plus B times D. Now let's apply these properties here. So this is equals to 5 times x minus 5 times 9 is 45 over x times x is x squared, x times minus 3 is minus 3x, 3 times x is plus 3x, and 3 times minus 3 is minus 9. We can simplify minus 3x plus 3x and we get 5x minus 45 divided by x squared minus 9. In our second example, notice that we have that this numerator is equal to this denominator. Therefore, we can cancel them and we obtain 5 over x plus 3. In example C, we have one fraction divided by the other. But we can convert this division into a multiplication because division is the inverse of the multiplication. And to do that, we switch the numerator with the denominator of the second fraction. So let's do that. So this is going to be 1 over x squared plus 4 times, notice here, denominator first divided by denominator. So notice I just switch the numerator to become the denominator and the denominator became the numerator. And now instead of division is a multiplication. And this is equals to 1 times x plus 2 divided by x squared plus 4 times x minus 2. 1 times x plus 2 is x plus 2 divided by, here we have x to the third minus 2x squared plus 4x minus 8. And that is our answer. In D, we also have the division between two fractions. So let's convert it into a multiplication by switching the terms in the second fraction. So as you can see here, I change the numerator with the denominator. Now we can multiply the numerators and the denominators. But before we do that, let's refresh an algebraic property. The multiplication of the addition of two terms times the subtraction of the same two terms is equals to the square of the first one minus the square of the second one. The reason why I brought this was because we have here x squared minus 4, which is minus 2 squared. Therefore, we can express this into two factors. X plus 2 times x minus 2. So let's replace that in the first fraction. So this is going to be 1 over, instead of x squared minus 4, we will write x plus 2 times x minus 2 times x plus 2 divided by x minus 2. Notice here that we can simplify x plus 2. And we get 1 over, and notice that here we have x minus 2 2 times. So this is x minus 2 squared. Now let's refresh the following. When we had the addition of two terms squared, this was equals to the square of the first one plus 2 times the first one times the second one plus the second one squared. And when we had a subtraction, we just switch the sign of the second term with negative. In other words, if we do x minus 2 squared, we're going to get a square of x, which is x squared, minus 2 times the first term, which is x, times the second term, which is 2, plus 2 squared, which is equals to x squared minus 4x plus 4. And that we can replace it here. So we will have 1 over x squared minus 4x plus 4. In example E, we have the addition of two fractions. Notice that both have the same denominator. Therefore, the addition is simply the summation of the numerators divided by the common denominator. In example F, we also have the addition of two fractions, which have the same denominator. Therefore, we just need to add the numerators, which are x minus 3 plus 1. This is equals to x minus 2 divided by the common denominator, which is x squared minus 4. Now, from here, notice that this is the difference of two numbers squared. And this was equals to the addition of the two numbers times the subtraction between the two numbers. In other words, x squared minus 4 was x squared minus 2 squared, which was equals to x plus 2 times x minus 2. So let's replace that here. This is going to be x minus 2 divided by x plus 2 times x minus 2. And from here, we can factor and cancel x minus 2, which means that the final result is simply 1 over x plus 2. G has the addition of two fractions with different denominators. Therefore, we need to use this formula. We will multiply the numerator of the first fraction times the denominator of the second fraction. Because the sign in the middle is plus, we will have here plus the denominator of the first fraction, x, times the numerator of the second fraction, y, divided by the multiplication of the denominators. This is equals to 3x minus 6 plus xy divided by x squared minus 2x. In example H, we have the subtraction of two fractions with different denominators. Therefore, we will proceed using this formula. x times x plus y. Minus goes in the middle because it's a subtraction. Then 5y times y divided by the multiplication of both denominators, 5y times x plus y. And this is equals to x times x is x squared plus xy minus 5y squared divided by 5 times x times y plus 5y squared. In our last example, we also have a subtraction between two fractions with different denominators. So let's proceed. This is equals to the numerator of the first fraction times the denominator of the second fraction minus, because it's a subtraction, the denominator of the first fraction times the numerator of the second fraction divided by the multiplication between both denominators. And this is equals to x times x is x squared minus 5 times 5, 25, divided by 5x.